Hello guys, Mr. G here with another video. This time we're going to be making another video on acid and bases. Please, before we carry on, subscribe for the channel so you can get all the notifications and videos I post on regular basis. Previously we spoke about the definition of acid and bases in terms of Brown-Tessalori theory. We learned that an acid is a proton donor and a base is a proton acceptor, and then we were able to identify acid and bases on different chemical reactions, as well as the conjugate acid base pair. Then we learned about ampholyte and amphiprotic. That was the last video we done, and we're going to be looking at another three important concepts today. But the first thing we're going to learn is going to be the monoprotic acid. Now the concept monoprotic, remember I said before, whenever the word protic is coming from protons, and mono, you're supposed to learn or know from previous topics, mono means one. So it's one proton. It's an acid that can donate one proton. That is a monoprotic acid. Example could be hydrogen chloride. Hydrogen chloride can donate only one proton. This is an example of a monoprotic acid. Now there is also a diprotic acid, and in diprotic acid, protic is still coming from protons, and di means two, so it can donate two protons. So a diprotic acid is an acid that can donate two protons. That is important here. It donates two protons. Example of a diprotic acid is sulfuric acid, H2SO4. This acid donates two protons, and previously we learned those steps in terms of donating protons. Okay. Now there is also triprotic acid. In this case, then it can be donated three protons, guys. And the example of this acid is H3PO4. So these are the first three important concepts. It's very important because they could ask you in the exam what type of acid is this one or that one. So it depends the number of protons that it can donate. But let's go to the other three important definitions that we are going to be talking today. Okay, so what is a strong acid? A strong acid is an acid that ionizes completely in water to form a high concentration of H3O+. So let's see one example. Let's say hydrochloric acid, HCl, which is going to be aqueous. Hydrochloric acid aqueous is going to react with water. What is going to happen is that hydrochloric acid is going to ionize in water. It's going to make ions, guys. So now in this case, it's going to be forming H3O plus aqueous, that was going to be ions in water, and it's going to form chlorine ions. So in this case, the concentration of hydronium is going to be very high. So high concentration of H3O+. That is important here because this one ionizes completely. So this is what actually happened. Now let's see strong base. But we can look at few examples that we have of strong acid, and those are hydrochloric acid. Those are examples of strong acid. We have a nitric acid, HNO3, and we have sulfuric acid. Those are common names of a strong acid. All right, so here we are. So that is a strong acid. Let's go to see a strong base, but the definition is more or less the same. Now, what is a strong base? A strong base dissociates completely in water. Dissociate is not necessarily the same as ionize. Dissociate is not exactly the same, okay? Dissociate completely in water to form a high concentration of OH ion. So in this case, now if you have a base, for example, sodium hydroxide, let's say you have sodium hydroxide salt, and this one dissolved in water, dissociates in water, is going to dissociate, it's going to break into ions. You will have Na plus and you will have OH minus. This is ions, and this is going to be ions in water. So let's add here the aqueous. Alright, so this is what is going to happen. Now what you need to know, if it's a strong base, then this one is a high concentration. High concentration of OH, and then this one dissociate completely. Now, how do you know it's a strong acid, a strong base or strong acid, guys? They're going to tell you that the following substance dissociate completely or incompletely in water, and then from there you can see if it's a strong acid or strong base. But now, strong bases, examples of strong bases are sodium hydroxide, potassium hydroxide, and any group 1 hydroxide is a strong base. Okay, so this one is quite important, guys. We have two new definitions: strong acid and strong base. Very, very simple definitions. If you have an example in exam and you want to know if it's strong or weak, all you have to know is to read. They want to tell you it dissociates completely or incompletely. That's all. Okay. Now let's go to weak acids and weak bases. Alright, now weak acid ionize incompletely. That is the difference here. Strong acid, as you can see here, ionize completely. Weak acid ionize incompletely in water to form a low. The concentration of H3O plus is going to be low concentration. Okay, this one is very simple. Let's see one example on a reaction. Alright, so we have here that hydrogen fluoride, for instance, ionize in water to form this one. What is the issue here? That the concentration of this one will be low. That is the problem here. Okay, and this one ionize incompletely. It ionizes incompletely. So that is the one there. And then we have two main examples of weak acid, and those are ethanoic acid and oxalic acid. You can remember that if you think you're going to forget. So now let's go to weak bases. So a weak base dissociates incompletely in water to form a low concentration of OH ions. So, for example, here is ammonia dissociating in water. The concentration of OH is low. That is why it is low concentration. Concentration, and this one dissociates incompletely. That is why ammonia is an example of a weak base. And some examples of weak bases are ammonia. There is also going to be calcium carbonate. For example, potassium carbonate and calcium carbonate. Those are some examples. They're not obvious the only weak base. But guys, this is the first four important definition we have here, concept. Strong acid, which ionize completely in water to form high concentration of H3O plus. Strong base dissociate completely in water to form a high concentration of OH ions. We have weak acid and we have weak bases there. Remember, the weak bases dissociating completely to form a low concentration of OH ions. So those are the four important concepts here. Okay, now to finish here, we're going to be talking about dilute and concentrated acid and bases. Now, solutions can be either concentrated or dilute. That is an important concept that you have to learn. Solutions can be either concentration or dilute, but this is not related to strong acid or weak acid or strong bases or weak base. We're talking about either of them. Now remember, the solutions are those that have the state of aqueous. Those are the solutions that we are talking about, and that means any one. It doesn't really matter if it's an acid, a base, a strong acid, or strong base. Any one could be a solution, and that solution could either be concentrated or dilute. Right? Now, concentration is the number of mole divided by volume. This is concentration and is the definition for concentration, amount of substance per unit volume. That is the general definition for concentration and is quite important there. Now, what is a concentrated solution? So the concentrated solution is the one that have a high ratio of dissolved substance. What is the dilute solution? Well, the dilute solution is the one that have the low ratio of dissolved substance to solvent. Okay, so let's look at this picture so you can understand what we are saying here. So we have on the left-hand side a concentrated solution. Within the same volume, you have more particles. So the number of particles here within the same volume is big of the substance that was dissolved. But on the right-hand side, you have the substance that dissolved is less particles. So there is more solvent than substance that is being dissolved. The ratio is a low ratio. You can see the difference there between concentrated and dilute. Now, this one have nothing to do with the strength of the acid or bases. So you can have, for instance, a concentrated solution of a weak acid, because that means that the weak acid dissolved in water in a high ratio, or you have a dilute solution of a strong acid, which means the ratio is low. So you can have, for example, here a dilute solution of hydrochloric acid, which is a strong acid, and that is what we call hydrochloric acid, but dilute, because that means that the ratio dissolved of the substance is low. So guys, this is all for now. I hope this concept is clear, because people attempt to confuse concentrated with strong. All right, concentrated is not strong. Okay, concentrated could be weak acid or strong acid. It doesn't really matter. But thank you for watching. Next time we'll go on to another concept. I hope this one is clear. It's not that bad. You can pause the video and go back and watch the definition. Thank you for watching. I'll see you next time. Mr. G here.